Today I want to show you something extremely common inside homes that most homeowners never even see. It's called a backstabbed receptacle. If you pull an outlet out of the wall, sometimes you will see a small hole that the wires are pushed into instead of wrapped around a terminal. That connection style is called a backstab, which is a little ironic if you think about it, but we'll get into the details why in the rest of this video. They are very common in residential construction, and technically they're allowed by code. But there are some very strong reasons why I highly recommend replacing them. So a backstabbed outlet holds the wire in place with a very small internal spring clip, which if you look close enough, might be able to see inside these things. So the installer strips the wire and simply pops it in the hole. Spring grabs the wire and holds it in place, ideally. The main advantage is speed, and that's really the main reason why it's used in new construction production homes. Most commonly is that speed, because speed is money, and go figure, money drives everything, right? But, you know, that's another topic. So the glaring question is like, well, Dwight, they're code compliant, so what's the point, right? Yeah, they are. And you know, I tell that to people too, because honestly, all this is a very strong recommendation based off my experience and the things I've seen from connections like this. So yeah, backstabbed outlets are commonly accepted by the National Electric Code to this day, if the device is listed for that connection. In the case of this one right here, it is listed for that use. It's literally the only way you can wire this specific outlet up, because there are no terminals on the side. So if your house has them, that doesn't mean your house is wired illegally. It just means that somebody prioritized speed over longevity. Manufacturers test them, and they technically meet the minimum safety requirements. However, minimum code compliance does not necessarily mean it is the most reliable or durable for the long-term solution. So the main problem with a backstabbed outlet is the fact that, like I said, it relies on a very small spring clip to hold that tension. So when that connection loosens, even ever so slightly, the resistance increases. When the resistance increases, the heat increases. See where we're going with this? And then with the heat increasing, your risk of fire increases. This is usually rare, but it happens. Generally speaking, heat is something you want to avoid when it comes to electrical. This isn't all the time, but more often than not I see it like this. When an outlet like this is wired up, it's wired in what we call a series circuit. Power comes into one outlet and then travels through the outlet, continues on to the next, continues on that way. That means that every outlet downstream relies on the connection of the one upstream of it. If one outlet fails, everything beyond that fails. It's very common to trace a bunch of dead outlets back to one outlet with a failed backstab connection. At the time that these were probably more commonly used, the electrical demand wasn't as high as it is in modern life. Devices like space heaters, hair dryers, space heaters especially, air fryers, vacuums, whatever, draw a lot of current. When you put modern loads on antiquated devices, it's usually not a good combination. So when that current passes through a weak connection, the risk of overheating increases significantly. I do want to make one important exception here. Not all backstabbed connections are bad. Some outlets use what is called a compression-style back wire terminal. This is commonly found on things like GFCI outlets, where you can push the wire in, twist it down, and a plate comes down on top of that wire and is cinched down by the screw. Those are totally okay. It's basically the same thing as a wrap-style terminal. Just want to make it clear that this issue that we're talking about is specifically with the spring-style outlets. So, proper terminal connections. Not this, but this. So the benefit of this is that wire has the entire terminal of the screw when it goes on it. So all that surface area to take current through, which is more than enough, assuming the breaker is properly sized. It creates a stronger mechanical connection and just better electrical contact, which reduces the chances significantly of heat buildup over time due to that thermal expansion and contraction. Now for a side wire, wrap that so you get this little loop. And this free end of the loop right here, that's the one that, as you tighten it, you want it to rotate this way. So what that would look like is come on, get it around your receptacle like that. I hold it in place with one hand so that it doesn't slide up. Cinch it down nice and tight. And that isn't going anywhere. Another factor to consider in this is the grade of, this is kind of informal, but the grade of device being used. You have builder's grade, which are extremely cheap, is what it is. It saves money on that new construction stuff. But they're cheap. They're not meant to last forever. That being said, if you upgrade to something that is like this outlet right here, the spec grade outlet, this is not a lot of money more. You're talking like 50 cents to maybe like $1 or $1.20 or something like that. I don't know off the top of my head. Most new homes, production homes, are built with those builder grade outlets that I'm talking about. Unless it's spec'd into it to where it's like, hey, I want these higher grade outlets. They're inexpensive, made with lighter internal parts and weaker contacts. Spec grade outlets, on the other hand, are built much more robustly. They have stronger internal contacts, better terminals, and are designed to withstand much more use in comparison. I know many electricians, including myself, prefer to use these style of outlets if we're doing a replacement for somebody. Why do I recommend replacing them so much if it's a code compliant thing? And it comes back to when we were talking about the heating and cooling cycles. Replacing backstabbed outlets improves the reliability of that branch circuit tremendously. It removes the weak spring connections and replaces them with properly secured terminals. It helps prevent overheating, power loss on your circuits, and any other kind of common outlet failures. Beyond that, fire prevention, which is what the entire electrical code is based around, is preventing fires. It's a hard one to talk about and not sound like I'm fear-mongering with anything safety related, but it's true. These devices like this are known to cause issues that can lead to a fire. I actually have a specific example that I came across recently where I was doing some temporary power for a restoration company of a home that burnt down, unfortunately, and the cause was a textbook electrical fire starting from a backstabbed receptacle, which I can show you some pictures of here. Bottom line is that it's a relatively inexpensive upgrade if you're doing it yourself that can make the electrical safety in your home much more dependable and just give you better peace of mind there. I recommend checking out a few outlets in your house, whether you have a brand new home, because like I said, I still see this done in new builds all the time, and especially if you have an older home. Point is, it's a thing, you should look at it, you should consider it. Another thing to take in consideration while I got you here, and it just crossed my mind, is that these 20 amp receptacles cannot go on a 15 amp circuit. The exact code reference for that, right here. I've seen a lot of stuff where it's a 20 amp circuit with 14 gauge wire. I know this is probably getting a little confusing, but that's dangerous. You don't want to do that either. Wire size matters. Breakers protect the wire. Yeah. So if you never look behind a faceplate for an outlet or a switch or anything, you're probably never going to know. Because what I tell people is that electrical works until it doesn't work. Hopefully when it doesn't work, it's not a hazard, but sometimes it is. That dwell time of when something is failing usually is a hard one to identify. So it's either perfect or far from perfect. Small details like how these wires are connected can make a very big difference in the long-term reliability and safety of your home. So that's why I recommend replacing your backstabs for a screw type connection.